We're going to take one break from quadratics for a week. We're going to talk about complex numbers. So what is a complex number? So complex numbers has this imaginary unit in it. Okay? So imaginary unit is going to be that I. So I is the square root of -1. Okay? So remember those graphs on our, we had these graphs that didn't cross our x-axis, right? We said there's no real solutions. Okay? There's no real solutions, but there are what we call these imaginary solutions. Okay? So that's what we're going to take a look at here beginning next week. But we're going to talk about what are these imaginary units and how do we deal with them a little bit this week. So, I is the square root of -1. Okay? If you type in square root of any negative number in your calculator, you're going to get an error message. Okay? Because it's not a real value. If I have I squared though, I squared gives us -1. Okay? Because square root of -1 times the square root of -1 gives us -1. Okay? So, pure imaginary numbers, square roots of negative real numbers. So, any number with an I on the end, okay? Or an I with the square root. Okay? Only one part though, no plus and minus in there. So let's take a look at simplifying these radicals. So if I have a square root, okay, again, square root, we're looking for squares. We're looking for numbers that repeat, right? So first thing I have here is this negative. So we're going to deal with that negative by taking out an I, okay? So first thing we're going to do is take out an I and make it positive 18. Okay? So that I, remember that I we took out was negative square root of -1. Okay? Now we can look at 18. If I break down 18, what are two numbers that go into 18? 6 and 3. 3's prime. What goes into 6? Yep. 3 and 2. So when I'm looking at these, my factors are 2 times 3 times 3. Okay? And again, we're looking for repeats, the pairs. So 3's are repeating, right? So that can get pulled out. So I have 3I. What's left is that 2. So square root of 2 is what's left. And that's my answer. So factor, look for pairs to pop out. So letter B. So again, pull out the I, making that positive. What are factors of 28? What goes into 28? 7 and 4. 7's prime, what goes into 4? 2 and 2. Again, looking for those pairs. So here's that pair, right? So 2I. What's left? Square root of 7. Alright, got a big number here, 125. So again, pull out the I, making that positive 125. What factors of 125? Okay, so 25 and 5. 5's prime, so what goes into 25? 5 and 5. So again, looking for that pair. Here's a pair of 5's. So that comes out. So 5I. What's left? Square root of 5. Questions on simplifying the radicals there? Okay, so do your factor tree, look for pairs that you can pull out front, okay, to make whole. Whatever's left goes back under the radical. Okay. Alright, so we have some operations here now. What if I'm multiplying with imaginary numbers? Okay, so again, multiplication order doesn't matter, right? So if I want to rewrite this, I could say 3 times 4 times I. And what's I times I? I squared, right? Well, what's I squared? What do we say I squared equals? We go back up here. Yeah, I squared equals -1. So that's kind of what I'm looking for when I'm multiplying with these. Okay, I'm looking for that -1. Where do I have any squares? So here's an I squared, so this is actually just -1. 3 times 4 is 12, and 12 times -1 is -12. So same idea here. Again, you don't have to rewrite it. I just want to show you that's what we're doing. Okay. So in our head, we're rewriting it in order, looking at my numbers. So -3 times 2 gives me -6, right? I times I is I squared, which makes a -1, and -6 times -1 is a +6. We can also do this with our radicals. So if I have two radicals that are negative, okay? So again, I'm pulling out that I out, right? So here I have I square root 20, and here I have I square root of 12. Now, if I have square roots, I don't want to multiply them together because I want to already factor it a little bit, okay? So I have I squared. So let's look at my factors of 20 and 12. What are factors of 20? 5 and 4. 5's prime, but 4 breaks into what? 2 and 2. What about 12? 3 and 4. 4 again is factors into 2 and 2 again. So I have my I, so I have I squared. And then what pairs do I have? Well, I have a pair of 2's. I have a pair of 2's here, so that 2 comes out. I have another set of 2's here, so this 2 can come out. And then what's left? Well, we use that for, we use this for, so I have a 5 and a 3. So what's 5 times 3? 15, so that's going to go back under the root. Now what do we say I squared was equal to? -1. So this is like saying -1 here, right? So I have 2 times -1, which gives me what? Yeah, -4, square root 15, and we're done. Alright, what if I have I to some big power? Okay? I to a big power. Now, we need to think about this. I squared is equal to -1, right? So, if I'm looking for a square, I'm looking for an even number, right? Okay? So, if I make this into an even number, let's make it I 30, that's even, right? Yes. Times one other I, that's 31. Everybody good with that? Now, how many squares can I get out of here? So I have this 30, right? How many squares can I take from 30? I need 2, right? How many pairs of 2 can I take from 30? 15. Okay, we're just dividing it by 2. Okay? So a pair every 2 is 15. Now, if I have, so really what I have is negative 1 to the 15th power, right? There we go with that. Does that make sense? Yeah. Okay. If I have 15 negative 1s all multiplied together, what's my answer? So let's think about this. Negative 1 times negative 1 gives me what? Nope. Positive 1 times a negative 1 gives me a negative 1. So 3 of them give me negative. 4 of them would give me positive. 5 of them would give me negative, right? So even number, 2, 4, give me positives, right? Odd number gives me negatives. So if I have 15 of them, what's it going to be? Positive 1 or negative 1? Negative 1. And this I can just come on down. So negative 1I, or negative I, is our solution there. Okay? Does everyone kind of see that? We're looking for those pairs. How many pairs can I pull out? Okay? Well, I can pull out 15 pairs, and those pairs are going to be at negative 1, right? And then I look at this 15. Well, this 15 is odd, so it's going to give me a negative 1 with one of these i's left over, okay? So if you look on the top of the back page, you can kind of see a chart there. And it kind of does kind of what we did here, okay? So it kind of works through a bunch all the way up to 8, okay? And kind of shows you what's going on there, okay? So when you look here, if I to the first is just I squared, negative 1. I to the third, well, we pull out an I squared, ni, so it's negative 1i. I to the fourth, positive 1, no i's left over. I to the fifth, we have an I left over, and it's going to give us a positive 1. Okay, so you can kind of keep going on down like that. Now, if I have I to the 17th, so let's think about this again. So we're looking for that pair, right? So let's separate this. I to the 16th times I. There's my 17 i's, right? Again, how many pairs can I take out of 16? How many pairs can I take out of 16?
You can take 4 pairs of 3 pairs of.
Nope. How many sets of 2 can I take from 16?
You can take 8.
8. Okay, again, we're just dividing that by 2. So 16 divided by 2 gives me 8. So negative 1 to the 8th power gives me a positive 1 or a negative 1? Positive 1, so it's just a positive I. Okay. Last thing here we're going to take a look at. So this is kind of where we're heading. What if I have an equation that looks like x squared plus 4? Well, we can solve for x squared on this now. So I can get x by itself, so minus 4 on both sides. So x squared equals negative 4 now. The opposite of a square is a square root. So if I square root, this square and square root end up canceling, and x is now square root of negative 4. But again, no negatives, right? So we're going to pull out that I. And what's 4 break down into? 2. So 2 and 2. So this pair here comes out, which then x equals 2i. Okay? So, and again, it's always going to be plus and minus. I should have said that. Okay? So we do have two solutions still. We have a positive 2i and a negative 2i. Okay? But again, this, if we graph this equation, it's going to be one of those no real solutions. Okay? So same idea here. So let's get x squared by itself. So minus 100. 4x squared equals negative 100. Still getting x by itself, we're going to divide by 4. So x squared equals negative 25. Square root, both sides. Once I get the square by itself, what's the square root of 25? 5. So plus and minus 5i. First step in letter C. What do we do first here in letter C? Minus 180. So 5x squared equals negative 180. And then what? Divide by 5. So 180 divided by 5. Negative 36. Then what? Last step to solve is what? Once I get square by itself, I do what? Square root. Remember, square root. So square root 36 or negative 36. So we have I. What's the square root of 36? 6. So plus and minus 6i. And then last one, letter D. First step is what? 2x plus 10 equals 0. What do we do first here in D? Subtract 10 gives me 2x squared, and then divide by 2. So x squared equals, well, negative 5, and then what?
Then x squared equals
square root, right?
Yeah, not x squared, x equals
Yep.
I square root of 5.
Yep, I and then square root of 5. Nothing comes out of 5. It's prime. So let's leave it in the square root. Pull the I out so it's not negative. Alright, questions on that? So these are the quadratics that we can solve by hand, okay, that just have an x squared in them. Okay, that are no real solutions. Next week we'll get into ones that have all three parts. Okay, so the three terms again and how we solve for those. Okay.